to everyday scenes. On the left, a pile of plates you add to the top and you take from the top. On the right, a line of people at a counter. You join at the back and you're served from the front. Both hold a collection of items, but the order things come out is completely different. The plate you added last is the very first one you remove. The person who arrived first is the first one served. These two rules have names. Last in, first out. That's a stack. First in, first out. That's a queue. By restricting where we add and where we remove, we control exactly which item comes out next. Let's watch each one move. A stack grows in one direction only, upward, from a base. It has a single working end, and we call it the top. Everything happens there. Push adds a plate. Push 10 onto an empty stack. It drops in as the bottom plate, and it's also the top. Push 20. It lands on top of 10, and now 20 is the top. Push 30. It sits above 20, 30 becomes the new top. Pop does the reverse. It removes the top plate and hands its value back. Pop now returns 30. The last one we pushed, and the top drops to 20. And that's the whole stack. Push and pop. Both at the top. Both taking the same tiny amount of work no matter how tall the pile is. Constant time. Order 1. A queue is a horizontal line with two working ends. New items join at the rear. Items leave from the front. Add at one end, remove at the other. NQ10. On an empty queue, it's both the front and the rear. NQ20 at the rear. Front is still 10. Rear is now 20. NQ30 at the rear. The rear moves along to 30. Deku removes from the front and returns it. Deku hands back 10. The oldest, the first one we added, and the front advances to 20. NQ at the rear, Deku at the front. And with the right setup, both are constant time. Order 1. Regardless of how long the line gets. Here is the contrast that makes it click. Feed the very same items, A, then B, then C, into a stack on the left and a queue on the right. Now empty them. The stack removes from the top. So out comes C first, then B, then the reverse of how they went in. The queue removes from the front. So out comes a first, then B, then C. The exact same order they arrived. A stack reverses. A queue preserves. That single difference is the whole point. Let's trace a real stack, one operation at a time, and read off the answers. Start empty, then run this list of pushes and pops. Watch the pile on the right, and note every value a pop returns. Push 5. The pile is just 5. Push 12 on top. 5, 12. Push 7. 5, 12, 7. 7 is the top. Pop. It removes the top, 7, and returns 7. Back to 5, 12. Push 9, 5. 12, 9. Pop again. It takes 9 off the top and returns 9. 5, 12 remain. And push 4. 5, 12, 4. Read off the answers. The pops return 7, then 9. The current top is 4. And 3 plates remain. 5, 12, 4. A quick check. 5 pushes, 2 pops, so 3 items left. It all lines up. Now the same discipline for a queue. Start empty, run these 6 operations, and record what each Deku returns. NQ is push in at the rear. Deku is pull from the front. NQ3. The queue is just 3. It's front and rear. NQ8 at the rear. 3, 8. NQ1 at the rear. 3, 8, 1. Deku. It removes the front, 3, and returns 3. 8, 1 remain. NQ5 at the rear. 8, 1, 5. Deku again. It takes the front, 8, and returns 8. 1, 5 remain. And the results. The Dekus return 3, Then 8. First in, first out. The front is now 1 and 2 items remain, 1 and 5. 4 inserts minus 2 removes leaves 2. Perfect. Here's where a stack earns its keep. Checking whether brackets are balanced. The rule is beautifully simple. Scan left to right. Every time you see an opening bracket, push it. Every time you see a closing bracket, pop one off. Let's trace this string. I'll walk each character and grow or shrink the stack of open brackets on the right. First, an open bracket. Push. Depth 1. Another open bracket. Push depth 2. A close bracket. Pop 1. Depth 1. Open again. Push depth to close. Pop. Depth 1. And a final close. Pop. Depth 0. The stack is empty exactly as the string ends. Every closer found a matching opener, and the stack finished empty. So this string is balanced. Now a broken one. Open, open, close. Same procedure. Open, push, depth 1. Open, push depth 2. Close. Pop, depth 1. But the string is done, and the stack still holds one open bracket that never got closed. A leftover on the stack means unbalanced. If instead a close had appeared with an empty stack, nothing to pop, that's underflow. And it's unbalanced too. In practice, a Python list is a ready-made stack. Append is push, and pop with no argument removes the last item. For a queue, reach for a DQ, a double-ended queue, where append adds at the rear and pop left removes from the front, both in constant time. One warning worth burning in. Don't build a queue from a plain list and call pop of 0 to remove the front. That shifts every remaining element down by 1. Order n work, slow on a long queue. A dequeue avoids it entirely. Where do these show up? Stacks run the call stack itself. Every function call pushes a frame, and returning pops it, which is exactly why deep recursion can overflow. They power undo and redo, and they parse brackets and expressions, just as we saw. Queues run breadth-first search, exploring a graph one level at a time, a preview of the tree and graph traversals ahead. And they schedule tasks and buffer streams of messages, holding items in arrival order until each is handled. Your turn. Here is a bracket string. Pause the video, walk it left to right, pushing on every open bracket and popping on every close, and decide whether it ends balanced. I'll wait. Let's check it together. Open, open, close, open, open, close, close. Open depth 1. Open depth 2, close depth 1. Open depth 2, open depth 3. Close depth 2, close depth 1. The string ends, but one open bracket is still sitting on the stack. 4 openers, only 3 closers. So this string is not balanced. If you spotted that leftover, you've got it. That's the stack technique in a nutshell. Trap 1. The classic. Don't cross the wires. A stack always removes the newest item from the top. A queue always removes the oldest from the front. Newest versus oldest. Trap 2. Underflow. Popping or dequeuing when the structure is empty has nothing to return. Always confirm it's non-empty before removing. That's exactly how an unmatched closing bracket gets caught. Trap 3. Using a plain list's pop of 0 as a dequeue, it quietly shifts everything down. Order n each time. Use a dequeue and it's constant. And trap 4. Forgetting to move the pointers. After every push and pop, the top must be right. After every enqueue and dequeue, front and rear must both be right. One stale pointer, and the whole structure lies to you. Let's lock it in. A stack is last in, first out. Push and pop, both at the top, both constant time. A queue is first in, first out. Enqueue at the rear, DQ at the front, both constant time when you use a DQ. Feed both the same items and the difference is everything. A stack hands them back reversed. A queue in the original order. Stacks give you the call stack, undo, and bracket matching. Queues give you breadth for search, scheduling, and buffering. Choose where you insert and remove, and you choose which item comes out next. That is the whole idea.